Hi students, this is Viswanath, Chemistry faculty for NEET and IIT exams. Now see the continuation. Azimuthal quantum number. It was proposed by Sommerfeld, symbol is small l. This azimuthal quantum number is also known as orbital angular momentum quantum number or subsidiary quantum number. This azimuthal quantum number defines three-dimensional shape of the orbital. Three-dimensional shape of the orbital. This quantum number symbol is L. Its value 0, 1, 2 up to n minus 1. That means the last value of L should be less than principal quantum number. Example, n equal to 1, possible L value 0. n equal to 2, possible L value 0, 1. Okay, say this last value 1, it is less than principal quantum number or not? Yes. Okay, in such a way azimuthal quantum number values are there. The values of L represents various subshells. L equal to 0, S subshell 1, P subshell 2, D 3, F subshell. In this way, based upon azimuthal quantum number values, we can understand what is the subshell present in that particular case. The order of energies of various subshells. S less than P, less than D, less than F. S subshell energy is less, F subshell energy is more. Next, angular momentum of the electron in an orbital equal to h by 2 pi into root of L into L plus 1. L is azimuthal quantum number. It can be written h cap. This is h cap into root of L into L plus 1. Okay. So in this way, about three-dimensional shape of the orbital, that means subshells, we can get information from azimuthal quantum number. L values give about subshells. What type of subshell is there? Next, magnetic quantum number proposed by Landy. It gives information about the spatial orientation of orbital with respect to standard set of coordinate axes. With respect to x-axis, y-axis, z-axis, how a particular orbital is arranged. Here orientation means direction. Spatial orientation means direction in a three-dimensional manner. With respect to coordinate axis, how a particular orbital is arranged. That is called, that information is given by magnetic quantum number for any subshell. 2L plus 1 values of ML are possible. Here ML is symbol for magnetic quantum number. M values are minus L, 0 plus L. From this 2L plus 1 we can get total possible magnetic quantum number values for a particular subshell. For example, L equal to 2 means, what is the subshell L equal to 2 means? D subshell. So L value 2 means what are the possible magnetic quantum number values? Substitute that in this 2 into 2 plus 1, that equal to 5. So L equal to 2, that quantum number having 5 magnetic quantum number values. Those are minus 2, minus 1, 0, plus 1, plus 2. Based on this I am telling. Okay. Next, the total number of magnetic M values indicates the total number of orbitals in the subshell. Here L equal to 2, magnetic quantum number values are 5. Those are minus 2, minus 1, 0, plus 1, plus 2 means in that particular subshell 5 orbitals are there. L equal to 2, what is the subshell? D subshell. In that D subshell 5 orbitals are there. Okay. So in this way, magnetic quantum number gives information about the arrangement of orbital in a three-dimensional manner. See that S subshell, how many orbitals are there? 1. P subshell 3. D 5. F 7. Okay. Odd numbers we can remember very easily. 1, 3, 5, 7. S, P, D, F. Next. The number of orbitals in a subshell equal to 2L plus 1. In a particular subshell, how many orbitals are there means 2L plus 1. Example, L equal to 0 represents S subshell. Magnetic quantum number values, how many? Substitute L value in this, we can get 1. So magnetic quantum number value is 0. So for S subshell, whatever it is, 1s, 2s, 3s, 5s, 7s, 4s, whatever the S subshell, magnetic quantum number value 0. L equal to 1, P subshell, magnetic quantum number values 3. Those are -1, 0, +1. Okay. How many orbitals? 3 magnetic quantum number values means 3 p orbitals, px, py, pz. Next, maximum number of electrons in a subshell is 2 into 2l plus 1. In a particular subshell, maximum how many electrons can be present means from this formula we can get 2 into 2l plus 1. It can be written as 4l plus 2. Both are same. Okay. Next, spin quantum number. This spin quantum number proposed by two scientists. Those are Goudsmit and Uhlenbeck. Symbol ms or s. Both can be used. The values of ms are plus half or minus half. These values represent two spin states of the electrons. Already we know that Earth also having self-rotation. About its own axis, Earth rotates. In the same manner, inside the atom, around the nucleus, electron also undergoes spinning, means self-rotation. In any orbital, only 2 electrons are possible. One electron is rotating in clockwise direction, other one is rotating anti-clockwise direction. So those rotations are called spin states. Electrons having 2 spin states, either clockwise or anti-clockwise. That means ms refers to orientation of the spin of the electron. The 2 spin states of the electron represented by upward arrow, spin up, or clockwise direction, downward arrow, spin down, or anti-clockwise direction. An orbital cannot hold more than 2 electrons, and these 2 electrons should have opposite spin. If we consider an orbital, inside that orbital we can accommodate maximum 2 electrons. More than 2 not possible, and these 2 electrons should possess opposite spins, not same spin. One is clockwise or spin up, another one is anti-clockwise or spin down. Generally for clockwise rotation we can use magnetic spin quantum number value plus half, for anti-clockwise minus half. Okay, so quantum numbers very important. More chance to ask a question from this topic in NEET and IIT exams, so prepare well. Next, see the important point. All quantum numbers, principal, azimuthal, magnetic, except spin quantum number, are obtained from the solutions of Schrodinger wave equation. Okay, so except these 3 quantum numbers, principal, azimuthal, magnetic, remaining all quantum numbers, principal quantum number, azimuthal, magnetic, are obtained from the solutions of Schrodinger wave equation, but spin quantum number we cannot get from Schrodinger wave equation. Okay, so what is Schrodinger wave equation? What are the solution? It will come in the next part. Next one, multiple choice questions. An impossible set of 4 quantum numbers of an electron is. Okay, see this one. First one, 4th orbit, n value 4, L equal to 2, possible, ml equal to -2, possible, because L equal to 2 means magnetic quantum number values -2, -1, 0, +1, +2. Here they give -2, so this is possible, this is also correct. N equal to 4, L equal to 0, S subshell, then magnetic quantum number 0, that is also possible. N equal to 3, L equal to 2, possible. Magnetic quantum number -3, not possible. L value 2 means magnetic quantum numbers -2, -1, 0, +1. Sorry, -2, 0, -2, -1, 0, +1, +2. But -3 is not possible. So see, this set of quantum numbers are not possible. Next, N equal to 5, L equal to 3, possible. M equal to 0, possible. So D option also possible, only option C not possible. See the next one. The quantum number L and the number of electrons in the sublevel, subshell, both are same, or related by 4l plus 2. Already we completed same point here. Maximum number of electrons in a subshell, this one. This we can write 4l plus 2. Same thing they give 4l plus 2. Option C is the answer. Next, number of electrons of manganese with magnetic quantum number value 0 is, in magnetic element, how many electrons having magnetic quantum number 0? Manganese atomic number 25. Electronic configuration 1s2 2s2 2p6 3s2 3p6 4s2 3d5. Okay, now write the quantum numbers. L equal to 0, s subshell, magnetic quantum number 0, that means s orbital. L equal to 1, p subshell, magnetic quantum numbers plus 1, px orbital minus 1, py 0, pz. These plus 1, minus 1, 0 fixed values for these orbitals, remember carefully. Okay, next, L equal to 2, d subshell, magnetic quantum number values minus 2, dx square y square. Remember, this is not minus, this is hyphen. Minus 1 dyz, 0 dz square, plus 1 dxz, plus 2 dxy. So these magnetic quantum number values for these orbitals are fixed. We have to remember. Okay. Now, how many electrons having magnetic quantum number 0 in this configuration? Say this. 1s orbital, magnetic quantum number 0. So how many electrons? 2. Okay, 2. 2s, magnetic quantum number 0. How many electrons? 2. 2p6. In that 6 electrons are there. Px orbital capacity 2, 2, 2. So with a 0 magnetic quantum number, how many electrons? 2. So 2p. Next, 3s, magnetic quantum number 0. Number of electrons 2. 3p6. In that also 3pz orbital having magnetic quantum number 0. So 2 electrons. 4s, s orbital, magnetic quantum number 0. So 2 electrons. 3d5, in that dz square having, in this 3d5, each d orbital having 1 electron. So dz square orbital having 1 electron. So 1. Add all these things, we can get 13. So what is the option? Option B is the answer. Okay. So practice well. In the next class we will meet.